For the Security Plus exam, you have to have a little bit of familiarity with the Linux command line environment, with Linux shells. But as is the case with the Windows command line and also PowerShell, you don't have to know everything about it. But if you feel inclined to learn more and more, there are all kinds of other training resources to dive into the details. First of all, Linux is case sensitive. Mike will have mentioned that in his overview. But there are various types of shells. It's not like there's one Linux shell and that's all that there is to choose from. So when you configure a Linux machine, it might have a default shell set up, or you can switch to another one. Now you might wonder, why would I do that? Well, first of all, we've got a couple of shells like C shell, the Korn shell, and the Born Again shell, or bash. People call that the bash shell. Each of them treats some commands, and especially how variables are handled, a little bit differently from other shells. And if you're already familiar with and like using, let's say, a Korn shell, maybe you'll configure it so when you sign in, that's the active shell. It's really a matter of preference, or maybe you're using an old script that only runs in a C shell. So maybe that would be your reason too. But the idea is that in Linux, a shell script is a text file where you've put all of your commands in it that you can run by invoking the name of that shell script file. Normally, a shell script has a .sh file extension, but in Linux, file extensions do not have the importance as they do normally in the Windows environments. So it doesn't have to end with sh, but it lets you automate repeatable tasks that you might normally find yourself doing manually in Linux. Put it all in a shell script, execute the shell script. Now, in order though for you to execute a shell script, which is really just a text file with your commands in it, it needs to be flagged as executable. We're going to talk about how to do that a little bit later using the change mode or the chmod command, but we'll save those details for then. The other thing about Linux shells is it's a security no-no to sign in with the super user account. In Linux, that account is called root. You should only sign into that when you absolutely have no other choice. 99.99% of the time, you have another choice. It's to use the sudo command as a prefix before any command that might require root privileges. Now, in order for you to be able to use the sudo command prefix to run those elevated commands, you need to be listed in a file called sudoers. Not just anyone could do it, otherwise, where's the security? Now, you can also access your Linux shell directly on your Linux host. Maybe it's just a Linux installation that doesn't have a graphical user interface, so it's just a terminal command prompt looking screen where you sign in and type commands. Or maybe it does have a graphical shell and you can launch a terminal window. Or maybe you're doing it remotely using free tools like PuTTY, P-U-T-T-Y. PuTTY is commonly used to make a remote SSH, a secure shell connection, to a Linux host over TCP port 22. And that's actually what I'll be doing when we go in to look at some examples of Linux commands. Okay, so I'm in a remote PuTTY session and I'm connected to an Ubuntu Linux server that happens to be running in the cloud. It doesn't matter where it's running. You can connect to it from anywhere as long as you can connect to its address. So one of the things that we want to talk about, because you could be tested on this on the Security Plus exam, is how to generate a public and private key pair for SSH public key authentication. Now, what does this mean? Well, we've already briefly mentioned, at least in theory, that what you can do is configure Linux authentication so that instead of signing in with the username and password, that's single-factor authentication because they're both one category, something you know. Instead of doing that, you can generate a unique public and private key pair, because we're going to generate a unique public and private key pair where the public key must be stored on the Linux server and the private key needs to be stored on whatever station you're using to make the remote SSH connection. Whether it's Mac OS, Linux, smartphone, Windows, doesn't matter. Either way, you need the private key on your device. That's what we're saying. So there are some commands that can generate these key pairs, and then there are some commands in Linux that can also be used to copy them to their appropriate locations. And that's what you might be tested on. So let's just see what that feels like here in Linux. The first command is ssh-keygen. I'm sure you can guess that means I want to generate a key pair. And I can even use -t for type and say, hey, I want to generate an RSA key pair. Remember that discussion in chapter 2? So at this point, it says, okay, enter the file where you want me to save the key. Now, notice the file name here is ID_RSA. You can change that. I'm going to accept it. That's the private key file. Even though it doesn't say that, that's the private key. That's the file you need on your device. Okay, it asks me for a passphrase. You always should password protect private key files, because if someone gets a hold of that private key file, they can essentially be you. So you should at least put a passphrase in to protect it. So I'm going to go ahead and do that. And then it asks me to confirm it, so I'll do that. Okay, so what does the output tell me? It tells me that not only do we have our ID RSA file, that's the private key that needs to be on your device, but we've also got a file that it called id_rsa.pub. I think I know what that means. Public key, that's the one that needs to be on your Linux host. Now, I generated these keys on the Linux host, so let's take a look at where it put those keys. First of all, in Linux, we can type cd, as in change directory, and just press enter, and that's a shortcut for getting into your home directory for the user you're currently signed in as, which I can see by typing in who am I. I'm logged in as someone called Azure User. If I type in pwd print working directory, it tells me the full file system path, and indeed, I'm in my home directory because I'm signed in as Azure User. If I type ls, oh, by the way, notice I'm typing clear to clear the screen. CLS won't work here. CLS is how you clear the screen in Windows. It's not going to work in Linux, so I'm typing clear as I'm doing these things. If I type ls to list any files in the current directory, I've got a Python script in here, apparently, but that's it. I don't see anything else. Well, check this out. If I run ls-a, the -a, and that's lowercase a because it's case sensitive, that means show me all items, even those that are hidden. All of a sudden, I see this stuff I didn't see before when I just typed in ls, like the .ssh hidden directory. Here in Ubuntu Linux, subdirectories show up in the color of blue. So I'm going to change directory to .ssh, type ls. There's the public and private key pair that was generated from ssh-keygen. So those files are okay. Now what we'd have to do, the public key is okay, but what we can do is we can use the cat file to display the contents of a text file. And our public key file is actually text. Let's take a look at that. Cat id rsa.pub. What we returned back here is the public key. So what we want to do, and I'm going to use the up arrow key to bring up that previous command, is I'm going to use the greater than sign, the output redirection symbol, because I need to put my public key in a file called authorized_keys. Now, if I already have other public keys there, I can append to it by putting in two greater than signs together. Anyway, authorized_keys. If we clear the screen with clear, and if I do an ls, there's the authorized keys file, and if I cat it, it shows me my public key. You can have more than one key there, but this is an important part of setting up SSH public key authentication. Now, just so you know, there is also the SSH-copy-ID command, which you could use to put those files in the places they need to be and to add the public key to the authorized keys file. I showed you manually. That can be automated using commands like SSH-copy-ID. So I'll clear the screen again. So one of the things I want to do is just point out the mount command. The mount command is used to mount a subdirectory on your machine to either a disk that you have or remotely to something shared on the network. You know how in Windows you can map a drive letter, like drive letter P might point to your personal home directory on a server somewhere? Well, Linux doesn't use drive mappings. It uses mount points, which means that you make a directory and then you mount a remote location or a local disk to it. If we look at the output here for my local Ubuntu Linux machine, I've got a mount point here that points to a device called /dev/SDA1. SDA is the first disk, 1 is the first partition on it. That is available when I go into the /mnt directory. So if I change directory to /mnt, I'm actually in the first partition, which has been formatted, of course, on my first disk device. Now, on the network side of things, we can issue commands like ifconfig. That stands for interface config. Here, what I'm seeing are my interfaces, like Ethernet 0 and my local loopback internal interface, LO, along with IP addresses. So I can see I've got a private IP address here of 10.1.1.5. Just like in Windows, I can also issue commands like ping if I want to see if a machine is responding over the network. So if I run ping www.google.com, it resolves the name to an IP address and I'm getting a return. For each echo request, I'm getting a reply. These days, though, a lot of firewalls will block that return echo, so you might not be able to use ping reliably anymore. I'll press Control-C to get out of that command. You can also use the IP space A, the IP address command, to also show network interfaces and IP addresses. It's really no different in terms of the output, not very different from what you get with ifconfig. But if you get an exam question testing your knowledge of ifconfig or IPA, they both return the same type of information.